Hello and welcome to Fouraye Academy. Today we will be continuing from the first part of financial. Last time we talked about the no arbitrage run period binomial pricing model. Now to continue from there, we'll first be looking at the wealth process, which is the amount of wealth we have at the specific periods. So x0 would denote the amount of wealth we have at time 0, and x1 would denote the amount of money we have at time 1. The way we calculate these wealth processes is that the wealth at time n is equal to the amount of stocks bought at time n minus 1 times the stock price at time n plus the money market position, which will be given by this, and this is basically our old wealth minus the amount of stock we bought and how much we bought it for, and we have this multiplied by 1 plus the interest rate, and this can be negative or positive, affecting our total wealth. Now with this concept, we can now know how to model different derivatives, financial derivatives in our model. So let's assume a European put option. Now a European put option will pay if the price goes down. So we could say that we have strike price K, so it will be K minus S1 as our thing, and it will be denoted this way, which means this, essentially taking the maximum between 0 and K minus 1. This notation is equal to this. So now how do we calculate the price of a derivative option based on our model? This model. So what we need to think about is how to balance the derivative with our wealth equation. So we say the derivative payout is V0, let's say, and X0. So how do we balance these? We say that X1H must be equal to V1H, and X1T must be equal to V1T. To properly discount these to their prices at time 0. So since we'll be discounting it, and since we only have one period, we'll have X1H equals V1H, and we'll be discounting this by one period, so 1 plus R X1H equals V1H divided by 1 plus R. Now to continue, we open it up as a previous wealth plus quantities bought at time 0, and then now you're discounting the stock price, which will be equal to V1H. And the same goes for S1T and V1T. This section is the stock price of S1 discounted to time 0, and this is the derivative option discounted to time 0. Now let's continue to make this even more easier to understand. Now we take this formula and turn it into this. which is a little bit more complex. Now remember, we had probabilities for whether it will be S or T. Now what we're doing here is we are essentially combining the cases for H and T, so we can find the derivative price at time 0. Now keep in mind, P cap and Q cap are not equal to P and Q. These are what we call risk neutral probabilities, which we will see now. So what we want to do to choose P is we want S0 to be equal to this, which will then make our previous equation make sense. So we want it to be equal to this. And it's the same as saying S0 1 plus R U plus D times P plus D. And now from solving from here, with a couple more steps, we can find that P is equal to 1 plus R minus D plus U minus D. Now these formulas given here, both for the risk neutral probabilities, the Welt process, and the previous discounted discounted financial derivative pricing formula, they're really important. And for Q cap, it's U minus 1 minus R, U minus D. So then from this, we can find what we call the delta hedging formula. Remember, delta is the quantity which we used in the formula. This formula is also really important. So in conclusion, if someone begins with, well, x0 at time 0 and buys shares delta 0 at time 0 again, then at time 1, the portfolio will be worth VH minus. And so what we say is that the derivative, the person doing this has hedged a short position in the derivative security. So this is the formula for basic hedging. In this model, at least. So we can now find the pricing formula, which is 1 divided by 1 plus R times the risk neutral probability P V1H. This was given before as well. Now these types of formulas will be seen a lot, and then we'll later shorten them by introducing a new kind of operator of sorts. So this is basically it. So to sum it up, we have our formula for pricing the derivatives. We have our Welt process. Minus, and finally we have our P and Q formulas. And also, of course, our delta hedging formula, which is relatively easy to remember. We have the derivative on top and the stock on the bottom. Of course, these are at time 1. And that's the sum, the summary of the 1-period binomial pricing model. In the next part, we'll be looking at multi-period models.